So let's run this game and see what we did last week. So I started a new game last week. I didn't abandon. I put the elevator game into storage. Let's put it that way. And I started this thing. Hopefully this won't make the stream explode. Oh, it did. Let's not do that. So you're this little. Oh, hello, random strings of letters. Welcome aboard. You are this. Let's try that again. It was running really slowly for some reason. This time, this is going to be the one. I can sense it. Yeah, here we go. So you're this little circular thing right here, and you can shove these asteroids around by flying. And the asteroids are all colliding with each other because they're like we got a physics engine running in the back of this. And I don't know if you can see it, but you can see like the player little sphere is actually like it's sliding along on the surface of the asteroids, and it's all very cool. And the idea for this was that so it's going to be like the idea was to make it like the original asteroids, where you can slice these rocks in half by like shooting at them or like flying at them or whatever you're going to do. But that is going to require some coding on our part, and that's the plan for today. We're going to try and get the slicing code up and running. It's going to be hairy. There's a lot of stuff. There's a lot of moving parts to getting that up and running, but we'll try our best. I have at least some kind of a plan of how to do it. InDev girl, welcome to the gang. I have a plan for doing this. We're going to do some ray casting. We're going to do some trigonometry and some stuff. It's possible we get this working in like half an hour. It's also possible this will take 3 hours, or we might not even get done today. I don't really know. One thing that also strikes me as I'm like looking at this just running in the background is if I click these asteroids a little bit so they start moving around, one thing that immediately happens is they start moving apart because there's no reason for them to move together again. There's like nothing. I mean, it's even worse right now because they sort of bunch up along the edges. But going forward with this game, I'm probably going to have to make some kind of like almost flocking behavior for the asteroids to make them like try and stay at a nice distance from other asteroids, so they don't all just like fly apart and never come back again, because that's not going to be fun. But we'll see. I mean, I don't know where this game's going at all. So we'll see. We'll deal with that when we get there. So the first step today is going to be getting some ray casting up and going, so we can like make a little ray going from the player ship out, and actually render that in the level and see what that looks like. And I think I just right before the stream started, I added some stuff because I was cheating. I added a little full screen toggle and a button to actually exit the game faster. Full screen and exit buttons. Okay, so looking at this code here, what do we have? We have the mouse down thing. This gives us the mouse position in the world. So I think what we're going to need to do is oh, who's that? I'm too slow. Bit of Barney, welcome aboard. Let me look at these little my little documentation here. I did prepare this beforehand, the docs for the array casting, so I wouldn't have to do this that I'm doing right now, but I lost them. Right, so I need a segment. That's what I need for the array casting. Kozilek! Awesome. He's a rad guy. I like him. So, setting everything up, I am going to need to create a var, let's call this array. And that is a B2 segment. Do I have those? I don't. Oh no. Okay, that's not good. Array cost. Oh, it just wants 2 points. That's interesting. Daryl, welcome to the gang. What do I need a segment for? And Sven, Mr. _ Discovery. There's no real, I'm just looking at the chat now, Richard, there's no real reason not wrapping the edges. I might do that. It's gonna be a hassle with the physics engine, but I think it's gonna be possible. I can't see why it wouldn't work. I mean, yeah, it could be hairy with the physics engine, but we'll see. Yeah, actually, I don't think I need that segment thing. I just need 2 points. So let's just ignore that. And we'll make a little function for this. Make a function called, let's call it, what should we call it? Excuse me while I use all the programs on my computer simultaneously. Yeah, having them wrap would solve the asteroids floating away thing, but you could also get the situation where an asteroid is like right over here and it's leaving, so it enters. Let's just, for argument's sake, say this is the screen right here. So an asteroid is leaving here, meaning it's entering here. It's a big slow one. There might be a small one going faster, like this direction here, that also gets wrapped and then just suddenly appears inside of this. Because, and I mean, there are ways to get around that with leaving like a buffer area outside the screen for them not to do that and stuff like that. But this situation could occur. I don't think it's not necessarily catastrophic. I think the physics engine might just deal with it, and it would be happening off screen probably, so you wouldn't necessarily see it. But this is the issue that I'm worried about when doing that. But that is still like way off. We got to do the fire laser function first. So when the chat is distracting. So when firing the laser, I need 2 points. I need a start point and an end point. Let's do this. So the ship is right here. The poor asteroid is here. The laser will go from like either inside of the ship, just in front of the ship, won't really matter, like that. So I need this point and I need this point. I think to begin with, I'm just going to do it with a mouse because it's easier for testing. Welcome to the club, Pixel Headshot. So what I'm going to do is I'm going to hook this up to the mouse up and down events. And I am going to make a little maybe I should split this off into a separate class. Maybe that's a good idea. Let's maybe do that. Let's make a little class right here. Call it laser. And this will have 2 points. IGman 2005, welcome to the club. It's going to have a start point, public var start. Let's make it a B2 vector. It might be a point also, but a B2 vector, same kind of thing. And also B2 vector. And when I initialize this, I might as well just set them to 0, 0, both of them. And then we can get rid of the fire laser function here. And we can add a public function called fire. Wintry, welcome. Let's call it fire. That's cool. So on the game code side, we will make a laser. And in the init here, we will actually, let's do it in the reset, like here. Laser, new. Laser. Cool. This is probably going to need reference to a bunch of stuff, but we'll add that in as we need it. So, wow, Napo13. Maybe having this follower thing it's going to be really annoying. But hey, welcome. Okay, so when I press the mouse down, I have this code in here already that will it will figure out where in the world I press the mouse, and it will give me the coordinates of that instead. So that's what I'm going to use for the start point. I'm going to add this as a function down here. Function get mouse in world. Awesome, 1019. Welcome to the club. So, mouse down. I enjoy free bacon. Also, welcome to the club. Mouse in world. And then we're going to set that point. Start x equals to world point. I could probably clean this up a little bit later, but this will do for now. Ilarsi, hello and welcome. Right, so we got the start point, and the same thing's going to happen when the mouse goes up. So it's going to get the mouse position in the world, and it's going to set these on the laser. And actually, for debugging purposes, we might do this. Var mouse down, it's a Boolean, that is false. So when the mouse goes down, we'll set this to true. Don't need that bit. Mouse down is true. When the mouse goes up, we'll set this to false. And we'll add a function that runs every time you move the mouse, so we can easily see what's going on. Call this mouse move. Microjam, welcome to the club. I got a mouse move handler. Add this down here. So mouse down happens first. Mouse move happens kind of in between. So this would just like, this is some duplicated code right here, but this is not going to stay in anyway, so that's fine. And finally, when I release the mouse, I am going to fire the laser. That's cool. So now, in theory, we have all the stuff hooked up for the position of the laser. Now I want to make sure I can render this so I can see that it's actually working. So somewhere in the world update here, I am drawing the debug data. I'm going to hook into this. So I'm going to do a line style thing. It's going to be a red line. Now, the question is, oh, well, we'll just try this at first. This is probably going to be wrong. But we'll do it this way anyway, just to see what's going on. Activate Windows now. What the fuck? Okay. I don't know what that's about, actually. That's alarming. I've had this computer for 2 years. I have no idea what that means. We'll see what this does. This is probably not going to be exactly what we want, but something. Oh, and I'm running the C++ version now. That's going to be interesting. So if you look up in the corner here, there's something going on up there. It's obviously way too small because I think I need to multiply with the physics scale thing. Or actually divide by it. That might do the trick. I should stop running the C++ version because it takes longer to compile. I'll try and remember that next time I compile. Here we go. Okay, so that actually worked. That's nice. So every time I click, it will move the line to where my mouse pointer was. And because I forgot to actually use that Boolean thing, so if mouse down, so if mouse down is false, we will just return and this code will never run. Oh, and I forgot to change it again. Oh, well. Come on, come on. That seems to be working. Oh, right, when I set I should be setting the endpoint here as well. Oh, I forgot it again? Really? How stupid can I be? I am using OpenFL. I like it. It's not perfect, but it works for me. Yeah, there we go. Now let's change this to be not HTML5. We want Flash. Let's just try it in Flash as well. Make sure it runs. Way it runs. Actually runs a little bit better even. That does not make any sense at all. So, what are you saying in the chat? Yours and Cactus game was my favorite of all the Super Game Jam games. Thank you very much. That's very nice. I hope it wasn't too confusing to play. Am I going to add my own style to the game? Absolutely. I think so. I'm not even really sure where this is going yet, so we'll see. But it's all about the programming right now. So we got this line going, and we'll have to, I guess we'll have to assume that it's in the correct positions in the actual physics world for now. And now we can get into the ray casting. I'm just going to commit this first. So can I assume unchanged for this? Oh, well, we got the laser and we got the game, and let's add that one too for good measure. So we got laser start and end points probably working. So now in the laser, when it's going to fire, we're going to do the ray cast. To do the ray cast, as best as I understand, I need a reference to the world, which is a B2 world, which is like the world that the physics engine is running in. So we'll do that. Now we have the world. Let's do this. And we'll give it a reference to the world. Everybody happy. So now in laser, when it's firing, we can go world, ray cost. I don't know what all and one do. So let's stick with this one for now. Can I get some documentation up for that maybe? Ray cost. The world for all fixtures in the path of the array. Your callback controls whether you get the closest point, any point, or end points. The ray cost ignores shapes that contain the starting point. That's good, because if we're like, we don't want the ship, so we can start the ray safely inside the ship. So that's cool. I'm wondering what the ray cost 1 does. Will it just return one fixture? And raycast all. I suppose that will return all fixtures. Really, I mean, we want all fixtures, I suppose. Let's go for ray cost 1 for now, and just assume that returns the 1. So we're going to go from start to end, and this will return a fixture. Nothing else? Will this return more? Yeah, this is a cool callback. Yeah, this is the one we want. This has a bunch of rad callback stuff. So this one's a function that will take a B2 fixture, a B2 vector, another B2 vector, a float, and then return dynamic. So we'll make one of those. Function ray cost callback. And now I am somehow supposed to remember fixture, B2 fixture, and then so we got the point and the normal, and then we got the fraction. I could probably copy this. Haha. Saved me so much time. Not really. And as far as I can remember, it says dynamic in the thing, but I think it's supposed to return a float. What are you guys saying in the chat? Are you using the library? Well, I'm using OpenFL, which is, It's for rendering and stuff. That's why I get the graphics stuff from. So like I can just type out this stuff to get things on the screen, draw stuff. And I'm using Box2D for the physics right now. So that's as far as the libraries go. Can HackC generate an Objective-C Xcode project for iOS? Yes, it can, or OpenFL can, and other libraries as well. Sven's thing can do that as well. I don't use the console for Git anymore. I do sometimes, and I use my little client sometimes. I try to vary myself. So now we got this raycast callback thing. We got the fixture. How do I go from the fixture to the body? Do something like world get. Maybe the fixture has a reference to the body. Oh, it does. That's very practical. So let's just trace out some stuff here, see what happens. Fixture point X, point Y. Let's try that. And I'm gonna look at the callback should return the new length of the array as a fraction of the original length. By returning 0, you immediately terminate. By returning 1, you continue with the original array. Blah, 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 blah. So I want to return 1 here for the time being. Meaning it might hit multiple things, which is fine. So I hook this up here, raycast callback, and I use the start point, and I use the end point. This should make something happen. I hope. Hang on, I'm gonna so keep your eyes down here for the console. Hey, something happened. A B2 fixture at 14.9. That's in the physics world coordinates. I have no idea if that. If these coordinates are correct, but it seems to be doing something. That's very cool. Oh shit, I should try it for 2 things as well, see what that does. Let's do 3. Oh my god, it actually worked. I didn't expect that. How many can I do? A lot, it seems. That's very nice. So let's try and render that little point that we get. I wonder how we should do that. Let's do another. I'm going to add another debug layer on top, because the problem is going to be this debug draw thing that the physics engine uses. It gets cleared every frame, right? So if I have something like the laser that's going to be happening over and over again, it might not be the best idea to have it. Or it's either that or storing these, and I don't really need to store them right now. So let's do that. Let's do a second debug render thing. Hey, Bob the Nice Zombie, welcome to the club. Debug render 2. That's a pretty excellent name for something. New sprite, add child, debug render 2. And because we're going to be shitting, let's make it static so we can get at it from anywhere. Hey, Subsidion. Welcome to the club. So we've got debug render 2, which means in debug render 2, we can go game, debug render 2, graphics. We can do this in fire, we can clear. So if there was anything there before, we just remove that. Debug render 2 graphics, line, style, 1 pixel wide. Let's make it a green circle. Draw a circle at, and now we are in physics engine coordinates, so we need to go back. So we go point x divided by settings, physics scale, and point y. And let's make it a 4 pixel radius. That should make something happen. Let's try that. Ha! Look at that. That is absolutely glorious. Very, very nice. I'm super happy about that. Look at it go. It even gets the start and the endpoint correctly. We can intersect the player right here. We can probably do it for these as well. Yeah. Yeah, so it will hit them if the race starts outside and goes in. And it obviously, like, once they start moving, it won't actually update. But that's very, very nice. So one thing that's going to be a problem, I think, is that the raycast only gives you the point where it enters, and really we need this point as well. But I am thinking we can just raycast from the other direction as well to get that second point. Sven, what are you talking about? It seems to miss some. Yeah, it's only the entry point for now. And the plan for fixing that is raycasting from the other direction as well. This is I'm super excited about this. This is really, really nice. I'm happy now. I could quit this team right now and be happy. We're not going to do that though. I think we're going to do the raycasts the other way around as well. The question is, how do I do that and still maintain entry and exit points? Because I suspect it won't. It's like I do this and the physics engine is the documentation is very clear that if I go like this, it will give me all the collision points, but it won't necessarily give them to me in the order they happened. So it won't be like 1, 2, 3, 4, 5. It might be like 1, 2, 3, 4, 5. Meaning that if I go the other direction, they might not come in the same order either. I mean, it depends. It might work. It might also not work. Oh, hey, Broken Rules. Welcome to the stream. So I think what we're going to have to do is that we're going to have to fire the rate twice, and then we keep a little dictionary or something. Let's make a dictionary. Those are cool. So do var hits, and we'll make that a map indexed on B2 body, I suppose, because that's going to be the one, or B2 fixture. I don't know. Maybe fixture is better. Let's do fixture. And then some kind of custom data structure, I suppose, for that. Let's figure that out. So we'll make it a type def. Laser hit. It will have an entry that is a B2 vec. It will have an exit that is also a B2 vec. I think that's all I need. Did I type the type def correctly? I did not. I was supposed to have commas like that. Unexpected public. Oh, right. Laser hit. Dino puncher, what are you asking? Exit point with the closest collision along the original vector. I'm not sure what you're asking. It's going to be like for this one here, boom. It's going to be this point. It's going to be that point. Exit is the one we're missing right now. So this is going to happen in two little chunks. It's going to be first a raycast that way, and then it's going to be one from end to start. There are probably smarter ways of doing this, but this is practical and nice. So that will work for me. So when this happens, it will, let's just do a new map for hits. And we'll have a public variable, no, a private variable, so we can keep track if we're doing the start point or the end points run. So we'll set this to true before the first pass. Then we'll run the second pass and set that to false. So that this way we can keep track of when they are happening, assuming these callbacks are actually immediate, but I think they are. We'll see about that. So what we can do now is we can, when this happens, we can use the map. What did I name it? Hits. Do hits get fixture. Actually, if it's, suppose I can only hit the fixture once. Dino puncher, what are you saying? If you put all the collision points from both raycasts into one group, then look at them along the vector of the first raycast coming from the ship. The closest point will be an entry point, the next exit, next entry, next exit. Right, yes, you are correct, but I'm not terribly worried about entry exit points. I'm more worried about which object they belong to. And doing it your way would require sorting. That would also work. That would also be about as practical, but I started it this way and I'm going to do it this way. So if we are running the find entry, I don't like that pass, but if we're doing that, we can be sure that this fixture hasn't been found before. So we can do, we'll create a new object with this this little data thing, laser hit. So right, and we need to actually keep the fixture around too. Will this work correctly if the ray hits a corner? I think so. We'll see. I mean, going forward with this, we'll probably want to discard really, really small pieces because we don't need them. Like they're going to be so small, they're maybe not even going to show up and they're just going to be in the way. So if we can figure out a way to detect if something gets really small or like really thin, we could just get rid of it and not deal with it. I mean, in part for performance reasons, but also just because of gameplay reasons, because there's no point in having them. So when we create this little type def thing here, we save the fixture, we save the entry point, the exit point is going to be null, and then we use hits set fixture is going to be the key, and the value is going to be hit. So this is going to be like a little lookup thing. So I can give it the fixture and it will give me this object back. So if this wasn't an entry, we're going to do var hit is hits get fixture. And then on the fixture, we are going to, no, not on the fixture, we're going, on the hit, we are going to set the exit point to point. Assuming the physics engine won't like fool us and give us a different set of objects when it's going the other way, this should be fine. We'll see, but I think this should be fine. And we can do a different color for entry and for exit. Let's do that. That should be fine. And we can do a little, I don't need that trace anymore, but we can do a trace here called found hits keys. Does that have a length property? It doesn't. Or does it? Iterators key remove set strings. No. Let's keep track ourselves. Hits found 0. Let's do that. Use the new funny hexy thing. Do this thing in a string. Okay, let's go. That was a lot of coding without any testing. We'll see how this works. Try it up here. Way! Entry point, exit point. Found 1 hits. Boom, 3 hits. That's very encouraging. 4 hits. 1, 2, 3, 4. That's correct. 5 hits. 1 hits. Like in the game, this, if we were actually making this into a full game, we'd probably discard something like this because it's not going to care about that. I love that you picked up on the profanity, Sven. I saw it myself and I decided not to comment on it. But really, like if the entry point and the exit point are too close to each other, we can probably just ignore them and we'll be fine. That's really cool. The alarming part is that this, I mean, especially in hindsight, but this was probably the easiest part of it all. Because now we're going to have to generate new geometry using these little points we've found. And at some point, we're also going to have to distinguish the player from the asteroids, because we don't want to start slicing the player up. And also these, like we really don't want to start slicing up the borders of the world. 5 hits. I wonder how many I can get. 9? Oh, that's cheating because I got that thing. 8 hits. 6 hits. That's pretty cool. Let's commit this. Super cool raycast and intersection finding. And in time for next week, I probably have it set up so you can actually try the game in real time as I'm working on it. I'll make a little script and make it upload to a web server so you can try it yourselves. I think we're gonna let's iterate over these for key in hits. Or actually, let's do 4 hits in hits. Trace. I suppose it's possible that we get objects with an entry point and no exit point, so we can actually quickly loop over and remove any of those. If hit exit is null, hits remove hit. I'm not entirely sure what happens if you delete from a map while you're iterating over it, but I think it's fine. So next step is going to be it's going to be hard. Because what? Oh, I can't do that. Hit fixture. Thank you, static typing. So next up is going to be, like, if let's say I slice this asteroid here. Let's move over to MS Paint. So I have an asteroid. That's an excellent looking asteroid. In every corner of the asteroid, there is a vertex. These guys right here. And when I am slicing the asteroid, let's use that. I will get 2 additional vertices. Get that one. And I get this one. So what I need to do now is that I need to work out a way to split these vertices, like figure out which side of the laser beam each vertex is on. So I can group these guys over here together into one and form a new polygon using those 2 vertices and these 2 new ones. And then do the same thing on the other side to make a new polygon here. And then we can remove the old one, which I think is going to be the easiest, and add these 2 in at the same position, or like an equivalent position. And then we're probably going to want to add a little bit of force to like make them float apart, but that's going to be easy. I'm not worried about that. I am worried about figuring out which side these vertices are on. And then, if you remember from last week, Box2D insists that you feed it the vertices in a specific order. I think you can start anywhere, but it needs to be counterclockwise, I think. So I can't go this vertex, that vertex, this vertex, that vertex. That won't work. So I got to figure out a way to consistently have the order correct. I think I should be fine if I, for this side, like the left-hand side of the ray, assuming the ship is like here. If I, for this side, start at the end of the vertices and go like last vertex, second to last vertex, blah, 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 until I run out of vertices, and then do the entry point and the exit point. I think that should be fine. And then I do the other way around on this side. So I start at the first vertex, go until the end at the exit point and the entry point. I think that should be fine. We'll see. So this is going to be the hard part. First questions first. How do I get at the actual vertices in a fixture? We'll see. For hits in hits, split hit. Very nice. This will take. Actually, let's do it this way instead. We'll do fixed hit fixture hit entry hit exit. Can I update this function definition? I can. Look at that Haxi being absolutely beautiful. I didn't get the data types though, but that's fine. Got the entry and we got the exit. Oh, who's subscribing? Malfury. Welcome. So now we've got a fixture coming in. That is going to be a B2 fixture. Oops, not a friction joint. So I didn't spell fixture correctly. That's fixture. Is there something like get? I don't get the body. I don't want to get the density. Get shape. Broken rules. Thank you for joining the club. I'm not entirely sure what it is I need here. Let me look at the documentation. And give shout outs to Everherb's subscribe. Trent Sterling, welcome aboard. Oh, I get it. So I do get shape. This will return a B2 shape, which is going to be a B2 polygon. Sorry, a B2 polygon shape. Clemons, welcome aboard. So this will give me the actual vertex data. The vertices must be in counterclockwise order for a right-handed coordinate system with the z-axis coming out of the screen. Cool. Let's see if this works. This is not going to work for the player. That's going to give me an error, but that's good in a way because I don't want to split the player anyway. Boom. B2 polygon shape. Very nice. Bam. Exception. This did not go well. That is fine though. So we can do if std is, this checks for what data type value is. And then we can do fixture get shape. And that needs to be a B2 polygon shape. If it's not, so exclamation point here, we just return. That should be fine. Sven, I'm using whatever's on Haxilib, so this is probably outdated to the max. But I am thinking I will cross that bridge when I get to it. Found 3 hits. What if I do that? It will say found 1 hit. I should probably add a little debug thing in here. Trace, removing hit without exit point. Yeah, I should probably be doing nape, but I have actually used Box2D before, so it was easier for me. Found 4 hits. Found 1 hits, removing hit without exit point. That's cool. So now we have the shape of this little fixture. What does this provide us with? Get vertices. That's exactly what I want. Get the vertices in local coordinates. That's cool. I have a sneaking suspicion we are going to want to get the center point. Is that not something I can get? M-centroid. Can I not get the M-centroid? Well, that's very helpful, Box2D, that you have it privately. Oh well, at least I know where to get it if I need it. It's in there. Yeah, discussing the physics engines in the chat. I'm pretty sure Nape is a better choice all around. It's just these streams mostly involve me going even if I know what I'm doing, and for this I am on unfamiliar ground anyway. So I chose Box2D because I know where I'm going with that. Oh my, we've been going for an hour already. I was so hyped this was going fast. Anyway, let's ignore the center point. I'm not even sure I need it. We have the vertices. That's cool. So now we're going to split these into two groups, like the left-hand group and the right-hand group. I'm not entirely sure what the best way of doing that is. I'm thinking we could do some kind of dot product thing. I'm really bad at dot product. It's not something I'm super experienced with, but let's try it anyway, just for kicks. So vertices, what is that? It's a B2 vec. So B2 vec, I'm guessing. I'm guessing this class has a dot product thing already. B2 dot. B2 math, B2 dot. Here we go. That's nice. So let's just trace some stuff. Vertices are indeed in local space. Yes. It's probably going to take some doing. I might just transform them into world space. I'm not sure if it's easier to because with this, like these are in local space for the asteroid, and the asteroid might be spinning and doing stuff. So this coordinate system, like inside the asteroid, is going to be different from the coordinate system for these two. So I'm not sure if bringing the entry and the exit point into their coordinate system is going to be easier, or bringing all of these out into the world coordinates is going to be easier. We'll see. Let's do these guys into the local coordinate space for now. Fixture. Do the fixtures not have a coordinate space of their own? Is it just the body's coordinate space? I'm using it down here somewhere. Get fixture lists, get mouse in world. Does the shape have a coordinate space? No. So I suppose it is the body that is the place to go. Body, fixture, get body, body, get local. We got the local center here. Maybe that's what we need. Not entirely sure. So we're going to do get local vector. Oh, what? So the entry and the exit points are going to be in world space. So we can get the local entry point by doing that. We get the local exit by doing that. I think we'll see. And then we'll do a dot product. I have no idea what I'm doing now. So let's just try that. I know for sure I can do angles for this. So if they're like down here is going to be like 180 degrees. But I'd rather not do that. Let's just trace these and see what we get. Get vertices, blah 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 blah. Local entry, and v. I have no idea what to expect from this. Maybe a semicolon at the end of the line. And maybe an extra parenthesis too. We'll see. Boom. We got a bunch of stuff. Some positive values and some negative values. I suppose this also depends on yeah, we'll see. We'll try some debug rendering for this as well. So let's do var dots. That. And where's my little debug render? We'll draw some circles for these as well. But instead we'll do dot is bigger than 0. If it's bigger than 0, we will draw with that color. If it's smaller, let's do orange. And we want to draw at the, I think that should be fine. And just to differentiate, we'll make these a little bit bigger. Bloop. That didn't draw the vertices at all. Why not? Oh, it's drawing up here. Right, because it's in the local coordinate space. That makes sense. So this lets us actually confirm that body gets world point of the local point. That the transformation between the world and the local coordinates also work because we're going back and forth here. We got something. It's split along the wrong axis, like it's 90 degrees off. That's very interesting. That is indeed very, very interesting. Why is it doing that? I mean, starting this, I didn't even know what to expect. So I suppose this is progress. consult documentation a little bit. Maybe I need to actually yeah, I don't know what to do about this. Because the entry point isn't really a vector right now, but we're treating it as one. So I suppose I should actually use the entry point and the exit point to make a directional vector. And try using that, see what happens. Local entry, subtract. That will give us a void. We don't want that. Add VV, is that vector vector? Awesome. But we don't want to add though, we want to subtract sub VV. Just want to make sure that this function actually does what I think it does. Sub VV, what? Subtract. Helps if you can spell. Subtract VV. Yeah, that's exactly what I want. Subtract VV, local entry, local exit. Let's try that. See what happens. I really don't know what I'm doing right now, so this is just me randomly trying shit. That's the exact same result. That's discouraging. I mean, I can always fall back on the angle math. It just feels sloppier. Can I? I'm also wondering what happens if I if I rotate it 90 degrees, what that would do? I gotta remember how to rotate a vector 90 degrees. It's swapping the two values and flipping the value of 1, I think. So if I have something that's like, this is 0, 0, this would be 1, 1, 1 on these axes. And I want to rotate that 90 degrees. Actually, no, let's make it 1, 2. That means the y value would be negative x value. The x value would be the y value. Does that make sense? I think that makes sense. Let's try that. So that becomes that. So negative x. Who's subscribing? Quirinus, welcome aboard. You have arrived at a very confused time in this stream. Does that make sense? So the x value, which would be 2 here, and the y value, which would be 1. Lawrence 18, also welcome. X value is 2. That means the y value is negative the x value. Is that what I set it to do? Yes, and the x value. I can't do that. I have to do TMP. Let's see what that does. I'm very excited to see what this is going to make happen. That looks promising. Holy shit, did it work? Wow. That one is technically on the wrong side though. That's annoying. Sorry about that. It is fine as long as I don't get too close to the... That is way, way, way wrong. Do I need to transform it into the center as well? I probably do. Because right now it's like a direction from here. What happens if I enter right next to one? That seems fine. That's wrong. This is going to be such a pain. Why is that not doing it? I have no idea why this is behaving like it is. Because like this is going to cause a bunch of pain later. Because I'm going to try and assemble like a shape out of this, and it's going to be this point, that point, that point, this point up here, and then that point, which is not going to work because it's going to be a non-convex shape. That's unfortunate. Well, I'm happy that it works as well as it does. I'm just messing up the math somehow. But I am considering just ignoring that and moving on for now. Can come back to that later. Because it is kind of sort of working as long as I'm not hitting too close to any of the points. Like this is not. This is really bad. I don't want that. How can it be like that? Is it because it's like doing it at the center? If anyone in the chat has any bright suggestions, I'm happily taking them. Seems some of them are just deal with it in a worse way than others. I honestly don't know what's going on. Maybe I should let's commit this. I mean, it doesn't work, but let's commit it anyway. And we'll try the angle method instead. So I got the local entry point and the local exit point, and then I can get the ray angle by doing that Yeah, that'll work. Local entry X, no, Y, minus local exit Y, local entry X minus local exit X. This will give us the angle of the ray inside the thing. And supposedly I should be able to calculate the angle maybe I need to, oh, right, I think I need the center point between the two entry points, because that's going to be like the pivot that everything's going around. And I can that's the one I can use to calculate angles from. Yeah, that makes sense. Let's save this and then go back a little bit. And probably don't need these. Got the split vector. Yeah, that will do. Split center, maybe. Which is a new B2 vec2, which is going to be the local entry point X plus the local exit point X. And then half of that, so giving us the average. And then half of that. So now we got an average point, and I think we need to transform the vector point to be compared to that before we can do the comparison. So we do split V, which is going to be B2 math subtract VV. It's going to be the V for the vertex and the split center. Let's see what that does. No. I'm hopeful. Still 90 degrees off, but we can fix that. Did I not? That's interesting. It's still 90 degrees off. It is rotating, but let's just ignore that for now. Okay, so let's go over this once from the beginning and see what's going on here. So we're getting the body, and we're getting the local entry points. because this is in world space, so we're transforming these to be local points inside the asteroid or whatever. And then we're figuring out the vector that we're splitting along, which we actually, now that I think about it, we might need to normalize that. Let's try that. Probably not going to help. Why does normalize return a float? Oh, it returns length. Cool. Whatever. Right now I'm just randomly trying stuff and seeing what works. I don't think we're going to have actually splitting asteroids before we run out of time today. Because like once I get this going, it's going to be the creation of dynamic objects and all that. I mean, this is making me hopeful. It's just 90 degrees off, leading me to think that if I do this, oh, I know what I did. I was overly eager with the undo key. Did you see that? It just changed color. That's making me hopeful. This looks a lot like it's working. They all seem to be correct. It's hard to tell when there's so many of them in one pile. If I do just to the left of that, that goes pink, pink, orange, orange. I got it. This needs to be committed right now. Array intersection split stuff works. I'll take a pass over this and actually comment everything. Get the angle the split is happening along. Get the center point of the split. We need this to calculate angles leading to which we in turn need to figure out which side a vertex is on. Rotate the split vector 90 degrees because of reasons. I'm still not entirely sure why we need to do this, but it seemed to work. And then we iterate over all the vertices to figure out which side of the array they are on. That is very nice. Actually, I will just add that to the last commit. Okay. So now we have these points. I have no idea in which order they arrive. and we're going to need to use them to make new asteroids. And I'm not entirely sure what the best way forward for that is going to be. So this runs. I'm going to take a look at the code I have for creating asteroids, because that is something we're going to need to do. Create asteroid. Here we go. So this little guy, something we... Hello, Debastante. Welcome to the club. This little guy is something we wrote last week. We don't need that line. So this is... I'm thinking I'm going to reuse this because most of it is going to be the same, with the difference that the first time we're making an asteroid, we're going to be figuring out the positions of the vertices ourselves, because we're going to do the like a little circle, like an offset circle kind of thing. But when an asteroid is made from the collision, we're going to have like an already made set of vertices. So my thinking is that I will split this up into like a create asteroid and a generate asteroid, maybe. Yeah. So generate asteroid. It's going to do this, and this actually uses an array of B2 vectors already, so that's probably what we're going to do as well. Hang on. Right, array of B2 vec2. That's all cool. And then we're going to have to do some work with applying the position of the old asteroid, the one that we split, onto the new ones. Oh, that's not going to work. Can I? I'm guessing I can probably do this on. So this is going to give me back a B2 body. Set the position. Yeah, that will. That will work for our purposes. So we just move this little bit of code up to here. We don't need that anymore. Try that. Float should be, oh, right. So we want generate asteroid up here instead. That seems to have worked just fine. That little bit of code works as well. one thing you realize when you're doing this type of work, like physics engine type stuff, and also other programming, but especially physics engines, is that debug rendering really helps. This would have been nearly impossible to work out without having it render on screen, so I could see like, okay, these are left hand hits and these are right hand hits and all that. I'm still mystified that I actually managed to work out the math for that, but that's cool. So yeah, let's just try. Actually, I just realized I didn't even need the center, or I haven't needed it yet. Let's just try making a new asteroid from these. So we got split, we got the fixture, we got the body, we got all that stuff going. So we're going to do left, which is going to be an array of b2 vec2. Plop, plop. And we got right, which is also going to be an array of b2 vec2. So we're going to do if dot is bigger than 0, we are going to add it to the left one. I have no idea if these are actually the left ones or not, but we'll find that. We'll figure that out eventually. We are going to push the v value onto there. It's going to go on the right. I suppose we could do this just because it's fun. Don't try this at home. Yeah, that should work. This will give us lists of vertices for left and right sides. And once we have that, I suppose we need a function to actually create the asteroids as well. This might need some moving around later, but we'll just do this for now. So create asteroid, and then we will give the laser. Where are you, laser? Here, access not only to the world but also to the game. Which is not. This is not a way I would design things, because it gives laser access to way too much stuff, but it will work for now. So yeah, let's just try it immediately because I can't wait. Create asteroid left game, create asteroid right. And one thing I'm not entirely sure if we can do this before, or we can do, or we need to do it before, or we can do it after. We also need to, excuse me, we need to get rid of body. Wonder how I do that. World, destroy, body. There we go. Body. Something's gonna happen. You guys excited? Unknown identifier. Game. What? Oh no, it's not game here, it's this. Exciting times. Boom. That didn't work at all. We got nothing. So that might mean many things. Let's take a look at what's actually going on in here. It might mean, yeah, it might mean many things. Let's stick to that for now. So I'm mostly interested in what's in these guys, the left and the right lists. So we got X, 0. You know, this all looks fine to me. So 0, 1.7, we're really far down. Minus 1.7, 0.93. I'm thinking this is counterclockwise, but I might be. Oh well. I'm sure the destroy thing works. The question is, does this work? It's creating the body. Oh, I'm not setting the position at all, am I? Isn't that tiny? It should be tiny polygons because like the entire world is like a 30th of the pixel size of the world. So those values are in a reasonable fixture list, shape, vertices. We know these numbers. I think they should be fine. I think it's mostly that I'm actually not setting the position at all. So let's wait with destroying the body until the very last. Left asteroid. Oops, can't spell. Left asteroid. Right asteroid. Let's ignore one of them for now. Oh, I can set position and angle. That's nicer. You just copy these values over to it. See what that does. Well, we got something. Oh, right. It's just, this is just two. I gotta stop splitting them so we get. Look at that! Oh my god! Split one with multiple vertices. That is it a real physics object too? Seems to be. That is incredibly exciting to me. Fucking hell. Oops, I should stop swearing. Well, you get what you pay for, guys. This is very exciting. So suppose we got that. As long as they have more than 4 vertices in them, this should still work. If we do that, just look at that. That's just beautiful. Yeah, I'm not doing the entry and exit vertices yet. I just want to make sure it works without them first. And it does. That is super, super exciting. Splitting works short of entry and exit vertices. Who is following my stream? Jingo Mapringo. Very nice username. Good job. So now we're going to think about this. So assuming the left side is indeed the left side, I mean, they seem to be working just fine. So I can assume the order they come back in is in counterclockwise order, meaning that on the left side, I should be adding Tej connects, welcome aboard. On the left side, I should be adding, either adding them at the beginning. Let's say I add them at the end. So it's going to be, this is going to be the 0. It's going to be 1. That's going to be number 2. That's going to be number 3. That's counterclockwise, right? So for left, I push first the entry one. And then the exit one. Who is following my stream? Slovenbot. Robots are also welcome. That probably needs to be the local entry and the local exit, by the way. We'll try that. If that's not correct for this side, it's going to be correct for the other side. Something happened. Seems to be fine. I mean, except that my left side is actually the right side. It is indeed working. And then I gotta consult my little drawing here. For this to be counterclockwise, assuming this is 0, this is 1, that is 2. It's gonna be the same thing, right? No, that's clockwise. That's wrong. That's gonna be 0. It's gonna be 1, and that's gonna be 2. So I'm just gonna add them in the other order. Like that, and then it should be fine. I mostly learned coding by myself. Whoops, that was not fine. That was fine. That is weird. That is not the way no. Might be just dumb luck that it works sometimes. Let's begin with actually working out which one's the left one and which one's the right one, because so let's disable the rightmost asteroid. Boink. That gives us, yeah, this is the right one. So that is not the way it should go. That means I should be able to just flip that. And we'll add them the other way around. Yes, so left is the one that's still around. That's not good. Why did that happen? Oh, if it happens, I don't know why that would happen. Whoop, assertion failed. That's not good. What are you asserting? Inertia has to be bigger. Oh, well, it's probably just really small or something stupid like that. Oh no, it's probably because the shape size gets messed up when I create them incorrectly. Oh, I think I know what's going on. So what might be happening, or I think what is happening is like I'm slicing this like here. And if I'm lucky, the order of the vertices is fine. Because it starts somewhere, right? Like this one's going to be the first one or something. So say it pushes this one on the list, and then that one on the list, and then that one on the list, and then that one, and finally this one. Or actually, no, that was the wrong way of saying it. So like when I'm creating this asteroid, right? It starts somewhere. Like this one right here is probably the first vertex I add, and then it's this one, and then it's that one, and it's that one, and that one. So if I slice it like along this way, does that make it messed up? No, that was fine. Because I'm thinking it is adding, yeah, that was not good. It might be when it's just, no, it's different times. Seems like slicing from the top down makes it happen more. So I'm thinking I might need to keep track of the exact dot product and sort on that or something to figure out where in the order I should put in the two new vertices. Because it might go like, this is number 1 or 0. Like this is the first vertex I get. This is the second one I get. This is the third one I get. And then I add in 4 and 5. Making everything just completely messed up. I'm not entirely sure how to solve that without... Hey, Swiss cheese, welcome. I'm not entirely sure how to solve that without making a huge mess of things. I can probably store them in a list and then sort it. Possibly using the dot product. Brady! Welcome aboard. I think that's what we're going to have to do. We're going to have to sort using the dot product to that specific point. Dot product's pretty fast, right? So I won't even need to... Yeah. Yes. Yes, yes, yes. That's the way to do it. So I can go, instead of doing this, let's just ignore the right side for now. So if dot is bigger than 0, we just go continue. That would just discard anything that would go on the right side. And then I can go so I think I'm going to loop over the list of vertices that I already have. I is smaller than left length if the dot product of the value I want to add, which for here is going to be v, and compared to left I, if that is either bigger or smaller, we want to keep going. Let's do smaller. Is this a stupid way of doing it? It probably is. Maybe it's smarter. This is going to be faster, but we don't really need fast right now. Is there a way I can do this without having to sort everything? I suppose I can do it this way. It's ugly and it's terrible, but it will work. So let's go back to everything being perfectly normal, and then we do, because they are arrays, right? So I can go left sort, and then I give it a function. Sort vert. This little sort vert function is going to compare the dot products with the center. Is that going to work? Might work. Let's just, I don't know. I keep changing my mind for this. Let's just do a custom thing. I really want this to work before I stop streaming. I just hit 2 hours. That's sad. Maybe this is as far as we get today, and we do the sorting next week, because this sorting mess is going to take. It's going to take time. What now? Oh, it's the assert again. I don't care. Keep going. Oh, it doesn't want to. This makes me very sad. Yeah, I need to sort them on the angle they have to the center point, or something like that. But that will only, I mean, it will be fine for my case. It'll be fine for spherical sort of things, like convex shapes. But if, actually, no, won't even need to deal with concave shapes because the physics engine won't deal with concave shapes. So that's fine. I think. Yeah, because the center point is actually guaranteed to be inside the thing. This is tricky. Tricky. Let's disable these for now. And we can take a look at what we have so far. Because I think we're gonna actually end the stream very soon. Because this is gonna be another hour of mayhem if I keep going with this. Can I? Yeah, I can make this full screen. That's cool. So you can fly around here, right? And you can go boom. And it won't actually add in these guys right here. It'd be very helpful if I could get like the order of the vertices, like getting the next vertex from one vertex. This game runs really slowly too because it's not compensating for frame rate at all. So it's really slow now. And that won't work. It actually gives me, can I collide with this? I can. That's fascinating. But they won't rotate, no. Did I crash it? I think I crashed it. Yes, assertion failed. Such a pity. Oh, it recovered. That's cool. Concave shapes won't be an issue because the physics engine doesn't deal in concave shapes at all. It deals with concave shapes by forcing you to ST Della, welcome aboard. It deals with concave shapes by forcing you to split them into multiple fixtures, which is the thing this runs on anyway. It doesn't necessarily support multiple fixtures in one body right now, the splitting. And for our purposes now, that is just fine. But one day, you know what we could do before we end the stream? We could make it also inherit the velocity. That's some low-hanging fruit right there. Set angular velocity, body, get angular velocity. Set just linear velocity and body. You are correct, Trent Sterling. It's just that ordering that thing is going to take some doing. So if I make these guys spin a little bit, oh, that's a lot. But hey, let's put it along there. It's not entirely correct because it's like should be. That's not the way it should go, but these physics are terrible. Like if I make this guy spin right here and I split it, boom. It's sort of like each individual piece will continue rotating the way it did. Can I? No. Lukexi. Welcome aboard. I'm thinking this is as far as I'm going to get today. I'm sad to end on not getting it to work 100%, but I'm also pretty hyped to getting it up and running as far as I did, which was actually a little bit further than I was expecting to get. So that's cool. Yeah, let's go into closing mode here. If you have any questions, ask them right now, and I'll answer you. Benny02 or something like that. Also, welcome to the stream. I'm happy with progress today. After all, it was a lot of work, a lot of math, stuff that I'm not really familiar with, but I learned some stuff. In the background, you can see that I am making alcohol for myself. That's cool. It's like bubbling away back there. Unless you guys have any more questions, this is going to be it for tonight. I am going to take a little break, get some food, and I'll see you guys next week, because I am streaming now every week for Central European time, which should be early in the morning, US time, like East Coast, and super early in the morning, American West Coast time. And this video will also go on YouTube, so you can watch it there if you want to. And yeah, that's all I got for today. Thank you so much for watching. You have been a great audience. Bye.